Hey Amanda, I wanted to go through this problem that you asked about. The first thing you want to know is, remember that if we have log base a of m plus log base a of n, remember that we can combine these logs by multiplying m and n under a single log. So this is going to be log base a of m times n. The reason I did that is take a look over at this left-hand side. You see we have the log of two things being multiplied together, or being added. So we're going to do the same thing. We're going to bring those together and we're going to multiply the x plus 8 and the x minus 8. So when we put these together, it's going to be log base, again, it's the base stays 6, and then it's going to be x plus 8 and x minus 8 inside this log equals 2. So again, you can see what we did is we took these two separate logs and we combined them through multiplication, just like what we did over here with this rule. So now that we did that, let's go ahead and FOIL this out. So x times x, so we're going to have log base 6 of x times x is x squared. Again, all I'm doing is foiling these two in here. X times negative 8 is negative 8x. 8 times x is positive 8x. 8 times negative 8 is negative 64 equals 2. Now what happens to our middle two terms? Those are going to cancel out, aren't they? So what we're going to be left with over on the side is log base 6 of x squared minus 64 is equal to 2. All right, now we need one more property of logarithms, and remember that's if we have, it's how we convert between logs and exponents. So if we have a log like this, log base a of x to the y, remember the base, when we turn this over, the base of the log is also the base of the exponent. What's on the other side of the log, that goes up in the exponent. And then what's actually inside my log, you see, inside my log, this x goes on the other side. So let's see what happens there. So again, what's the base of our exponent? The base of our logarithm. The base of our logarithm is 6, right? Again, I'm just using this over here. What's on the other side of the equal sign in our log is 2. So this is going to be 6 to the second power is equal to, and then remember that what's inside the exponent, look over here, what's inside the exponent, that went on the other side of the equal sign. So this x squared minus 64 is over here. Sorry, let me write that a little bit neater. All right. So we went ahead and we got that written as one logarithm. So we started with 2 logs. We got it down to 1. Then we turned it into an exponent. From here, it's just a pretty simple quadratic to solve. 6 squared is 36 equals x squared minus 64. Now I'm going to try to get that x squared by itself, so we're going to add 64 to both sides. So 36 plus 64 is 100. So we get, let me add 64 to both sides. All right, sorry, I'm going to need to continue this over here. 36 plus 64 is 100 is equal to x squared. Now to get rid of the squared, I'm going to take the square root of both sides, so we get square root of x squared is equal to, don't forget to put plus and minus square root of 100. So we end up getting x is equal to plus or minus square root of 100. That's going to be 10 or negative 10. But we need to make sure we can't have negative logs. And you see that if we have a negative 10 up there, that's going to make both of these logs negative. So we know x cannot be negative 10. So our final answer is going to be x is equal to 10.